Hi, students. Welcome to video 19 on renewable energies. So before we even talk about renewables, one of the best things we could do to save electricity or to save energy is actually to be more energy efficient. So the United States could save 43% on our energy simply by using the energy that we currently are wasting. So this amount right here. The world, it could be about a third of the energy. So notice that there's a lot of input, and then this whole bar right here is just completely unnecessary waste. So if we did this, we could prolong our fossil fuel supplies, we could reduce the cost of the energy resources that we're using, and we could buy time to phase in some of these renewable energies simply by being more efficient. So here are some of the devices that are usually the most inefficient. It used to be the incandescent light bulb was a huge thing. You can't really even find them anymore. And that's because it was only 5% energy that was actually being light. The other 95% was being lost as heat. So today's light bulbs and the LEDs, they're 20 to 30, maybe even 35% efficient, which is a whole lot better. Coal combustion plants, where we get a lot of our energy, are only 30% efficient. So that means 70% of the energy is completely wasted in the form of heat. So what can we do about that? So for example, here's where you might put in the coal or whatever your fuel is. We're going to turn a generator. We're going to get electricity. So that's about 30% of your energy. But the other 70% is this wasted heat. So if we could actually recover that heat and use it to heat homes, that would be what we call cogeneration. So two forms of energy from the same fuel source. And this could really increase our energy efficiency. So we have had to do these things before. Back in the 70s, we went through the OPEC oil embargo, where Arabic nations basically refused to give oil to supporters of Israel. And one of the things that happened from that is we got corporate average fuel economy standards. The government basically said you can no longer produce cars and trucks that only give you 10 to 15 miles per gallon. So you'll notice that in the 70s and 80s, we really, really increased above 25 for cars to the point where now we're at about 33 miles per gallon for cars, and we're close to 25 even for trucks. The government also implemented a 55-mile an hour speed limit nationwide. So you could not drive 70, you had to drive 55. And so a lot of those 55-mile an hour speed line signs have still remained, although our interstates have gone back up to 65 or 70. Or if you drive illegally, it might be 80. So that kind of goes back to the 70s and what happened there. So we do have some things that we can actually do to improve energy. Why do we still use so many of these fossil fuels? Mainly because they are subsidized. They're made artificially cheap by the government. Oil, for example, if you included the environmental costs associated with, frack or drilling and things like that, it would be $12 a gallon. Can you imagine? So to fill up your car that averages maybe 10 to 15, gallons, that would be over $100 easily. So oil companies are lobbying against laws that would raise the fuel tax. However, if you did have an increase in oil costs, you definitely bet people would start putting money into those renewables more likely. But we're not doing that right now. So there are some things that we can do. So we can use solar. There are passive and active solar. Passive is when I don't have any pumps or any devices that I need. I'm simply using the sun. So in the wintertime, I have my windows facing the sun as it rises, and then I can heat my home that way. When I need a solar collector, like photovoltaic cells, when you think about having solar panels on your house, that would be an active solar. So I have to convert the sun energy into electricity, and I have to pump it through my house that way. So here are the forms of active solar. We can have a standard solar cell, like a photovoltaic cell. This is what we typically think about when we think of solar farms. Or we can have concentrated solar, where there's like mirrors that basically shine and direct the heat and the energy into this one area and concentrate it. So there's some trade-offs. The advantages, it is pretty moderate in terms of active solar to high, which is passive, the net energy. It does not have any CO2 emissions unless I'm having to produce solar panels. So that would be where the fossil fuels are used, and therefore I'm producing CO2. It is low cost if I'm doing passive, but it is kind of a high cost if I'm doing active. And unfortunately, I only have access to the sun during the day. So on cloudy days, it might not be so great. If we can find a way to, harness and store the energy, then we would kind of be at a much bigger advantage. So hydropower, we typically think of dams. Here is the lake that a dam makes, and then we use the elevation change and the kinetic energy to move the turbine that's in here. So the water flows from high to low elevation. It is an indirect form of sun because the sun powers the water cycle, and that's what's powering this. And it is our leading renewable energy for the world. So, some good things about having a lake and having hydroelectric power is the lake provides recreation, it gives us irrigation for our crops, it gives us drinking water. Um, Unfortunately, though, it floods all of this area that's back here. It also disrupts the ecosystem of the river, and so now fish, for example, can't go back upstream and migrate like they normally do. There are some risks of the dam bursting and flooding everything down river. So we've actually stopped doing a lot of dams in developed countries. Developing countries, since this is one of the best ones in terms of energy production, they are still utilizing hydroelectric power. So here, the largest one in the world is in China, the Three Gorges Dam. There's the Hoover Dam in the United States and the Aswan Dam in Egypt. But we are removing them. There's over 1,200 dams that have been removed in the United States, and we've basically been able to revive the fisheries and the river area for the entire ecosystem. We also have tidal power. So basically, the energy that we get from the tides coming in and going out. So there's no pollution associated with it. There's low impact, and you do get a pretty good energy return on investment. However, it's only good in a few locations. You need to have tides. It can be pretty expensive to install, and you have the risk of things like storms, hurricanes, completely destroying the entire area. So wind is the second fastest growing source of energy. In the United States, mainly we have like Texas and Oklahoma. North Carolina, you'll see down here, but our wind potential is pretty high, so we could move up. And again, this is also an indirect form of solar because you have unequal heating of the earth is what causes wind to begin with. So you can see from 1999, 20 years later, how much we've grown. Very few states were doing wind, and now almost every state is in some capacity. And we have grown from 2,500 megawatts to almost 85,000 megawatts. One big concern people have with wind is birds. However, it's really not that big of an issue when you think about other human activities. For every 10,000 birds that are killed by human activity, less than one is caused by a wind turbine. So most birds are dying because we've built really tall buildings and they're flying into those buildings. So one thing you have to consider is the migratory patterns of birds. So you don't want to put your wind farm in the middle of where you know birds are going to be migrating. So you really have to be, ecologically aware of what's going on. So we have biomass. This is plant materials and animal waste that we can burn and get energy. Mostly happening in developing countries because they have these things widely available. Have lots of wood, lots of garbage, sugarcane and different types of plants that we can burn. So it is widely available and it's not very high cost. It can be carbon neutral if you are harvesting and replanting so that the carbon is getting taken back up. It also has a pretty moderate environmental impact. It does cause some damage. The biggest issue with biomass is we're using our food to burn it and make fuel. And in a lot of places, we don't have enough food to begin with. So it's kind of like, why are you going to, take that food and burn it and use it for fuel if you could be actually feeding people? So that's kind of an issue surrounding biomass that we have to address. We can convert plants into liquid biofuels, so things like biodiesel that you think about trucks putting it, or really big trucks getting biodiesel. Ethanol we can also get from things like sugarcane and corn. And you'll notice worldwide there has been a spike in liquid biofuels over the last 20 years. Ethanol is one of those things that we put in gas. You'll see the 10% ethanol mix anytime you go to the gas station to fill up. And basically, what the government has done is they have subsidized these farmers to grow this corn to produce ethanol, even though the return on investment is pretty low. But we continue to do this because now we have a ton of farmers who basically depend on growing this corn, which is a monocrop, and we know there's some issues related to that. So the government is really encouraging the monocropping of corn to make ethanol and put it in our gasoline, even though it really doesn't do a whole lot. We have geothermal, which is the heat from within the earth. Here's the geothermal potential worldwide, and you'll notice it's along plate boundaries because that's where volcanoes are typically. Volcanoes in the western part of the state originate around this area, so that's why the geothermal potential in the United States is mainly just out west. And here's a geothermal power plant in Iceland, and you can see people are basically going and enjoying a spa experience. So if you ever go to Iceland, you should try this out. But the water is really, really heated and hot, basically like a hot tub from this geothermal power plant. So the advantages, you do get a high energy yield if it's not going to be, costly if you're in a place where there's a volcano. It's low carbon emissions and low cost. However, if you're not in an area that has, access to a volcano, it could be pretty high cost. It also can actually cause earthquakes where you're drilling down to get at the heat. And so there's a lot of noise related, and you can release hydrogen sulfide gas that's stored down around the volcanoes themselves. And the last one we have is hydrogen fuel. This one we haven't really talked about yet. So, hydrogen gas is not present on Earth naturally, but there are compounds that have hydrogen in them. For example, water. So, we can do electrolysis. And the way we do this is we actually take water and electricity. And we flow electricity through the water to make it separate into hydrogen and oxygen. This is how we get the hydrogen. The good thing about this is when we then basically the hydrogen fuel part is to combine the hydrogen and oxygen again. So the byproduct of this is just water, which is awesome because there's no carbon emissions in this. And then when they combine, they release heat, and that is how we get the energy from hydrogen fuel. So there are some challenges with this. It's very expensive. It's hard to store hydrogen gas. Hydrogen gas is also insanely flammable, so it's very dangerous to try to store it or to like transport it. You'll notice that the cars that are up here right now are very expensive, so about $50,000. If you can afford that, go for it. So there's very little carbon, even if but you actually can get carbon if you're using methane. So if you're splitting carbon and hydrogen from methane, because methane is CH4, you are still producing some carbon, which can add carbon dioxide to the. So what's the most likely to actually happen? More than likely, our natural gas is going to continue to go up a lot more than everything else. Coal is going to go up a little bit. Oil is actually coming down a little bit, or stabilizing at least. Our renewables are going up. Our nuclear and our hydro are kind of leveling out and staying about the same. They're not really changing. So this is the most likely situation that we'll actually see in the next 15 to 20 years. All right, that's it. Bring your questions tomorrow.